In this video, we're going to go over the Check Your Understanding from 2.1b. So I think this is Knoebels Amusement Park in Ellsberg, Pennsylvania, has earned acclaim for being an affordable, family-friendly entertainment venue. They do not charge for general admission or parking, but it does charge customers for each ride they take. How much do the rides cost at Knoebels? The figure shows a dot plot for the cost of each of 22 rides in a recent year, along with the summary statistics. Number 1 says, suppose you convert the cost of the rides from dollars to cents. Describe the shape, mean, and standard deviation of the distribution of rides costs in cents. So what's happening here is you would take all of these prices and you're going to take them and they all get multiplied by 100. So you are scaling the data. So as far as the shape, if every value gets multiplied by 100, it is still going to have the same shape, this skewed right, unimodal. So the shape's going to stay the same. The standard, the mean, so the mean used to be $1.705, but it's going to change by this multiple. So you're going to multiply by 100 and get 170.5 cents. Make sure to put units. And then lastly, we have the standard deviation. Now the standard deviation is also affected by this scaling up. It's also going to be multiplied by 100. So the standard deviation was $0.447 dollars, but we multiply by 100 and we get that in cents. And this kind of makes more sense now that we have some context about how the standard deviation is going to multiply. The mean will multiply, but the shape will stay the same of the distribution. So for number 2, now they want to increase the cost of each ride by 25 cents. So they're just going to take the values that they had and add 25. So realize that this is, so just an increase of 25 cents is a shift by 25, right? You're adding 25 to each one of your data values. How would the shape, center, and variability, like that spread of this distribution, compare with the distribution of cost in question 1? Okay, so we're taking from question 1 to question 2, so it's already multiplied by 100, and now we're shifting up 25. So the shape stays the same. You can just think of it as like a horizontal translation. It's just every data point's going to move to the right 25 cents. So the shape's going to stay the same. You know what? Let me keep the same color here. So same shape. The center, so now we can talk about the mean. So the mean's going to be affected. If you move everything up 25, the mean's also going to shift up 25 cents. And we can actually figure that out since we know the values. And that now the new mean is going to be 195.5 cents. And then the standard deviation or any variability, whatever we could find. Now everything just shifted up. So it's just as spread out. The max and the min are going to be the same distance away from each other. So any measure of variability remains the same. So your standard deviation will still be 44.7 cents. Okay. Your max minus min, you could do 300 minus 125. You could get that range. You could get the interquartile range. Okay. Now suppose you convert the increased cost from question 2 to z-scores. So we're going to standardize this. Just to remind you, to calculate a z-score, we would take all the values, subtract the mean, and then divide by the standard deviation. What would be the shape, mean, and standard deviation of this distribution? So every single price to get on a ride in cents, you take that value, you would subtract the mean, So we would always subtract 195.5. I mean, we're not going to do this by hand, but I just want you to understand. And divide by 44.7. And think about the mean is 195.5. And if I subtract that, it doesn't matter what I divide by. That mean is going to always be 0 once you standardize it. So the mean is always going to be 0 in a standardized distribution. And the standard deviation is always going to be 1. Because if we take all the values and divide, like subtract the mean and then divide by the standard deviation, that spread, that like deviation on average is going to be just 1 away from the mean. And the shape stays the same. Because when you're standardizing, all you're doing is you're shifting and then scaling. You're shifting by subtracting the mean and then scaling it down by dividing by the standard deviation. And neither of those things changes the shape. So as like a general statement, you could say all standardized distributions have a mean of 0 and a standard deviation of 1. All right, sounds good.